Hey everybody, welcome back. I'm Seth Monahan, a guy who's really glad not to be talking about sequences today. Instead, you're going to get the first of two lessons on what I call enharmonic wormholes. But before we talk about worms, I need to tell you a story about a cat. And not just any cat, Mozart's cat. You see, when he was young, Mozart used to spend a little time every day at his desk studying string quartets by his mentor, Haydn. And the cat would, hover. You know how cats are. Anyway, one day, Mozart knocks a score off the table by accident, and that was that. The twitchy beast goes airborne in a hail of loose pages, and study time was over. Or was it? Now, we all know Mozart's good for a laugh now and then. So as he's cleaning up, he pauses for a second over two random pages lying next to each other on the floor. These are pages from different pieces in different keys, and he just stops for a second to imagine how it would sound if a group played them straight through. Incoherent nonsense, obviously. But what he heard in his head surprised him. Now, if you've never heard this story, it's probably because I made it up, obviously. But while we're here, we might as well join imaginary Mozart in asking why this worked. How did we slip so smoothly into a completely unrelated key in the middle of a phrase, like the whole thing was planned in advance? Let's figure it out. Here is the spot where we jumped from one piece to another. Excerpt 1 ended with these chords, and then excerpt 2 from a completely different movement started here. Now, we're going to want to start by pulling them apart to see how each one works on its own. Excerpt 1 is from Haydn's second Opus 77 quartet, which was actually written after Mozart died. It's in F major, and the 6 bars I played you spun out a single chord, 5-7 of F. That's the chord we hear 6 times in just those last 2 bars. In the actual piece, what happens next is exactly what we'd expect. The C dominant resolves to the tonic, F major, where Haydn brings back the main theme. Now, excerpt 2 underneath is from a much earlier piece, the 6th and final Opus 20 quartet. The movement is mostly in E major, but just before the music on screen, Haydn slips for a second into E minor. And at the end of that stretch, we get a German augmented sixth resolving to a cadential 6-4. And that cadential 6-4 is drawn out, finally resolves, and then lands on the major tonic. Here's a recording. So, this is all well and good, but none of this explains why the stitch-up of the two pieces worked so well. But imaginary Mozart, he sees why. He notices, first of all, that the chord that ends excerpt 1 sounds exactly the same as the chord that leads into excerpt 2. Now let's be very clear. They're not the same chord. They can't be. They're spelled differently. One is C, E, G, B flat. The other is C, E, G, A sharp. But they still sound the same. Notice that this beat in Opus 77 is almost identical to this beat in Opus 20. And the fact that they sound the same makes this modulation possible. In other words, it's one of the reasons, not the only reason, but one of the reasons we can get to this point, and instead of continuing with Opus 77 number 2, we can slip right into Opus 20 number 6 instead. Terminology-wise, we'd say nowadays that Mozart's Happy Accident has produced an enharmonic modulation. Well, what's that? You might remember that the term enharmonic refers to musical events that have the same sound but different spelling, like the way this note can be written as A sharp or B flat or even C double flat. Okay, so what's an enharmonic modulation? I'm going to take my time and be as clear as possible with this. In some ways, an enharmonic modulation is just like any key change that uses a pivot chord. Remember, the pivot chord is the point where two keys overlap. It's a chord that lives in both keys and lets composers connect them smoothly. The difference, and this is a big difference, the difference is that an enharmonic pivot chord is spelled differently in each of the two keys it connects, but sounds the same regardless. In other words, the pivot chord isn't really one chord at all. It's two chords that relate enharmonically. It's two chords that sound the same. In the case of Mozart's Happy Accident, the pivot from F major to E major was this set of four notes on the piano. In the first piece, they were spelled C, E, G, B flat, which is 5/7 of F. But in the second piece, there was an A sharp instead, which makes it a German sixth in E. But you can't tell them apart just by sound. Now, notice how I keep saying the word sound here. That's not an accident. That's because this whole thing about chord spelling only matters to a point. Yeah, you have to understand it. But it distracts too many students from what really matters. And what matters are sound and musical experience. We will absolutely talk about chord spelling whenever we need to today, though we'll see that composers themselves can be inconsistent and even sloppy about it. That's because ultimately spelling and notation are just a means to an end, and that end is a particular sonic effect. But before we talk about the special sound of enharmonic modulations, I want to make one broad and kind of obvious point about pivot chords in general. Pivot chord modulations work because sounds mean different things in different contexts. More specifically, the way we understand, the way we hear a chord might change because of what comes after it. Here's a simple progression in C major. It has 3 C major triads, and all of them sound and feel like tonic. Now, if the next phrase starts on C, we're going to hear that as tonic too, obviously. But if it continues like this, and we modulate to G, things change a bit. Listening backwards, so to speak, it's clear that the opening chord is a pivot, and that we can also hear it as 4 in G major. This same idea holds with enharmonic pivots, but with a huge caveat. Enharmonic pivots are pretty much always dissonant chords, chords that contain tendency tones. And those tendency tones want to resolve in very particular ways. This isn't true with normal pivots. Our pivot chord here is a C major triad, and that triad in itself doesn't, quote, want to do anything very specific. A lot of things could come next. Compare that to Mozart's pivot chord in the gray block here. It sounds like a dominant seventh, which means it has 2 notes that demand specific resolutions. A chordal seventh that wants to go down by step, and a leading tone that wants to go up by semitone. But that's not what happens. In the stitch-up version, this downwardly mobile B flat goes up by half step like an upwardly mobile A sharp. And instead of rising, the leading tone E just stays where it is, eventually leaps an octave, and then drops by semitone to D sharp. All of this is why enharmonic pivots tend to be so much more surprising and dramatic than normal pivots. you've got powerfully charged tendency tones doing something other than what we expect. And young Mozart, well, he's a genius, so he not only grasps all of this pretty much instantly, he sees something he can use compositionally, a fantastic way to trick his listeners. You set them up to hear a particular chord as a 5/7, but then you resolve it as though it were an augmented sixth. And when that happens, you're going to end up in some remote key. This is why Mozart called this kind of modulation an enharmonic wormhole. In science fiction, wormholes are these space-time anomalies that allow for fast travel between different regions of the universe. They're basically intergalactic shortcuts. Are they real? Of course not. Did Mozart know about them? Give me a break. But they're a great metaphor for enharmonic pivots, which can give us a direct path between distant keys, and in a way that can seem more like science fiction than science fact. Listen to Mozart's Happy Accident again and see if you can hear what I mean. Now, as it happens, young Mozart was in a position to put one of these wormholes to work right away and within a single piece, not between two pieces. Earlier that day, he'd been working on the development section of his A minor piano sonata. And here's what he'd sketched out. You had the movement's main theme in the relative major C. Then a restatement that introduced two chromatic notes, D flat and B flat. And together, these clearly turn C into the dominant of F minor. And then after stalling for a bit, Mozart triggers an avalanche of arpeggios down C7 to land on F and start the theme all over again. But with the happy Haydn accident in mind, he sees an opportunity here. What if that long C7 resolved like an augmented sixth rather than a dominant? Great idea. So he keeps the first bar of the avalanche, but then rewrites the second one. He respells the B flats as A sharps and redirects the right-hand part so that it comes in for a landing on D sharp as part of a B dominant. So again, instead of this, we get this. And with that rewrite, he arrives at the version of the sonata that we all know and love, where F minor never materializes, and instead we get a long, supercharged 5 of E minor. Now, before we move on, let's take a second to notice here how I've analyzed the modulation itself. The bottom row shows correctly that bar 57 is a German sixth in E minor. But it's also our pivot chord, so we're doing that dual layer thing. And in the other layer, I've got 5/7 of F marked in scare quotes. It's in scare quotes because it's not actually spelled as 5/7 of anything. It's spelled like a German sixth. But to a listener who doesn't know the piece, it's going to sound like 5/7 of F until we go through the wormhole into E. So if all of this is clear so far, you won't have any trouble with my last 2 points. One of them is just that there are really only two kinds of enharmonic modulations, and today we're doing one of them, the kind that uses the similar sounds of augmented sixths and 5/7 chords. The other type uses diminished seventh chords, and they're going to get their own video. The second thing is that Mozart has done something here that's very helpful to students, but still pretty unusual. He actually shows us both spellings of the pivot chord, by which I mean we can look at the score and see a C dominant seventh here, C, E, G, B flat, and then see the B flat replaced with its enharmonic twin A sharp, which tells us that the chord's not going to resolve like a 5/7 at all. In other words, it's an enharmonic modulation where we get to see the enharmonic part on the page. Don't get used to this. Composers rarely spell out the pivot chord both ways. They're much more likely to just pick one. Mozart could have done that too. He could have pulled off this same modulation using just B flats in both bars with no A sharps at all. But in that case, we'd have to change our analysis. Now the scare quotes would be around the German sixth symbol since there's no actual German sixth on the page. Or he could have just used A sharps the whole time from the very beginning of the avalanche. Then the scare quotes would be around 5/7 the whole time, because now there's no actual 5/7 on the page. But I can't stress this enough. None of this matters for the listener, because the results sound the same. They're gonna hear this bar as 5/7 of F, no matter how it's spelled on the page, because that's what the context demands. As I said before, spelling is ultimately kind of a red herring. Sound trumps all. And that's why we were able to build an enharmonic wormhole between two entirely different pieces, because the sounds lined up to make it work. Notation be damned. Okay, if all of this makes sense, it's finally time to check out some more real examples. First up is Beethoven's second to last piano sonata, Opus 110. On screen is the climax of a long fugal episode in the tonic key of A-flat major. And the fugue subject itself is in almost every bar. We've got it here in its original form. Here at pitch in an inner voice, over here in the key of the subdominant, and then again in the left hand with a snappier rhythm. And as you'll hear, the passage culminates on a huge, drawn-out 5/7 of A-flat. That's an E-flat dominant seventh. Now, rather than consummate the fugue with some triumphant PAC in A-flat, Beethoven's plan here is just to leave the fugue hanging in mid-air and then slip back into the wordless minor key aria that opened the movement. Given the spotlight he's shining on E-flat 7, we're obviously meant to expect the music to be in the tonic A-flat minor again, maybe like this. But that's not what happens. Instead, and today this will be no surprise, instead he resolves that long 5/7 chord as if it were a German augmented sixth in a different key. And that key has to be G minor because, as I'm sure you remember, augmented sixth chords always lie a half step above the dominant note of a key. So when I play what Beethoven actually wrote, notice three things. First, notice how this tendency tone, the chordal seventh D flat, wants so badly to resolve downward, but instead, going through the wormhole causes it to shift up to D natural as if it were a C sharp instead. So instead of this, we get this. Second, notice how the chord that starts the second system sounds like a cadential 6/4, but it never actually resolves to a regular dominant. It just sort of slumps back down to a root position tonic. But third, and most importantly, notice the incredible, almost supernatural effect that this wormhole shift has, as if the exuberant rationalism of the fugue has collided with something beyond all human understanding. Now, if we jump ahead about 50 years, we hear this same trick used to a very different effect in Tchaikovsky's Romeo and Juliet overture. By this point in the movement, we've heard the long, slow introduction and the fiery strife theme in B minor. And what follows is the very famous love theme. And Tchaikovsky sets us up for this with a huge climax on A, the dominant of the relative major D. He then draws that dominant out for 20 bars, almost a full minute. The first phrase traces out a gradual collapse, with diminished seventh chords sliding around over a dominant pedal. Then the harmony sort of stagnates, focusing just on the actual A dominant seventh. And it would make perfect sense here if that languishing A finally just dropped, as a dominant should, to D, its tonic, ushering in the new theme. But no, that's not what happens. Instead, Tchaikovsky builds a wormhole to D flat major by resolving the A7 chord as if it were a German sixth. So instead of this, we get this. Now, that German sixth would technically be spelled B double flat, D flat, F flat, and G natural. But thankfully, we don't have to worry about that, because Tchaikovsky certainly didn't. He'd want us to focus instead on how that surprise resolution to a 6/4 chord makes the love theme feel less grounded and more like it hovers and finally takes flight. So, with all the examples we've seen so far, the enharmonic wormhole emerged from the normal dominant of the key, just the regular 5/7. And when that happens, it always spits you out a half step lower than when you started. But that's not always how it works. You can do the same thing with an applied dominant seventh, and that's just as common, maybe more so. This is the opening of Brahms' Requiem. It's in F major, but the second sound is an E flat. Way back in video 30, we learned that that note, flat 7, is often a signal that we're hearing 5/7 of 4. And we are. It resolves to 4 over a tonic pedal, then minor 4, and tonic. And as it turns out, Brahms is going to treat this as one of the movement's main motives. We hear it again in the second part of the orchestral intro. Probably deserve an actual orchestral recording of this whole passage. And then we hear it 2 more times when the voices enter with the text, "Blessed are those who mourn." So he's really drilled it into our ears by now. Well, at several points down the line, we find ourselves in the key of D flat major. The first time, Brahms gets back by just walking down the D flat major scale and parking himself on F, where he reboots the opening of the piece. The second time, though, he restarts the opening of the piece in D flat major. And then uses a mid-phrase wormhole to modulate up a major third to F. And the pivot chord is that 5/7 of 4 we keep hearing. By this point in the piece, we've been conditioned to hear this phrase wanting to continue like this. But instead, the thing that sounds like 5/7 of 4 resolves like a German sixth in F, landing on a cadential 6/4. And notice, not that this really matters, that Brahms is the first composer to spell his pivot chord in a way that looks forward rather than backwards. In other words, he spells it as an augmented sixth in the new key, not as a dominant seventh in the old one. Now, as usual, I have exactly no statistics to back this up, but I'm pretty sure that this particular move, modulating up a major third by treating 5/7 of 4 as a German sixth, I think this may be the most common enharmonic wormhole. An easy way to think about it is that we basically just turn the tonic into a German sixth of some other key. Here's another example, also from a very well-known piece, and once again we have a composer modulating back to tonic after a trip to flat sixth land. It's from Schubert's great B-flat major piano sonata, and it happens right near the beginning of the piece. The sonata opens with an idyllic pastoral theme in B-flat major, the tonic. But after it cadences, Schubert treats us to a variation of the theme in flat 6, G flat major. And as the theme goes on, it works itself into a bit of a frenzy despite being stuck on a tonic pedal point, and it climaxes with a dissonant chord that gets hammered out 21 times through an extended crescendo. And you can see on screen that that dissonant chord sounds, in context, like 5/7 of 4. And we can easily imagine it resolving to 4, maybe with some kind of triumphant return of the main theme in C-flat major. But of course, that's not what happens. The chord may sound like 5/7 of 4, but it resolves like a German sixth, which is, incidentally, how Schubert spells it. So instead of this, we get this. Here's how it actually sounds. So in the past two examples, we had genuine bait and switch modulations, by which I mean the context allows us to actually hear and process the dissonant pivot as 5/7 of 4 before we go through the wormhole. But sometimes things happen so fast that that's not really possible. This is the opening of the Scherzo from Clara Schumann's Piano Trio. The first phrase has a lot of slippery chromatics, but it's all anchored down by a tonic pedal. The parallel consequent phrase starts the same way, but the third bar opens up a wormhole that hurls us into D minor. Now, in a way, this is basically just the same modulation we heard in Brahms and Schubert. We modulate up a major third thanks to an augmented sixth with the old tonic in the bass. That's this chord right here, and she has spelled it in terms of the new key, D minor. Now, to be sure, if we freeze it in time, that chord on the downbeat sounds just like 5/7 of 4 in B flat. It wants to resolve to E flat. But when I play the actual scherzo again, ask yourself, is there really time to hear it that way? The chord lasts for less than 1/2 of a second. Is that enough time for us to, quote, expect it to resolve as a secondary dominant? Well, if you're me, the answer is no. And this isn't a special case, it happens all the time. We're in one key, and then all of a sudden we're on the dominant of the key a major third higher because the tonic morphed suddenly into an augmented sixth. It's still an enharmonic modulation, but man, does it feel different to me as a listener. If you can tolerate another sci-fi metaphor, it's less like passing through a wormhole and more like warping instantly from one point to another. I'll give you just one more of these for comparison. It's another piano trio. This one's by Schubert, and it's also from the Scherzo. The tonic of the movement is E flat, but the passage in question starts in the key of E major. That's sharp 1, if you're keeping track. And the theme we find there is an unassuming little dialogue between piano and cello. After about 6 bars, it modulates to B major, the key of 5, where we just kind of spin our wheels for a bit. The next thing to really happen is a lurch back to the original key of E flat. And the way Schubert does this is a lot like what we saw in Clara Schumann. We've gotten to B major, and we're just kind of vamping away on 1 and 5 when all of a sudden the tonic triad gets a 4th note, A natural. As spelled, this is 5/7 of 4 in B major. But there's no 4 of B major, and in fact, no B major at all. So this never actually happens. Instead, before the chord even resolves, we're back to a 3-flat signature, and if you listen to the progression across the double bar, it's the sound of a German sixth resolving to a cadential 6/4. So we've modulated up by third from B to E flat thanks to an enharmonic pivot that lasted maybe 3/10 of a second. It's just not enough time to process its double meaning. Though Schubert does something cute by backtracking to this chord, now spelled as a proper German sixth in E flat, one bar later, before resolving to tonic and relaunching the main theme. So if I've done my job today, you should be very comfortable by now with this idea that composers set up a chord that sounds like 5/7, only to resolve it as an augmented sixth. But maybe you're also wondering, does it ever work the other way? I mean, do composers ever set up something that sounds like an augmented sixth and then resolve it like a 5/7? The answer is yes, just not very often. But it does happen, like in the slow movement of Beethoven's First Symphony. The main theme starts out in F and eventually lands in the dominant C, but the second section of the movement sets out straight away in C minor. When I play this system, test out my theory that Beethoven wants us to hear this chord, despite its spelling, as a German augmented sixth. When I first heard this music, I thought for sure it would continue in C minor and maybe resolve into a big half cadence. But today's refrain is, that's not what happens. The thing that sounds like a German sixth actually resolves as it's spelled, which is to say, as 5/7 of D flat major. So instead of this, we get this. Here's how it actually sounds. So what happens next? Well, we have to make our way back to the tonic F, but we do it through another wormhole, except that it's the more familiar kind that uses 5/7 of 4 as an enharmonic pivot, just like the Brahms Requiem and just like the Schubert Piano Sonata. After dallying in D flat major for a bit, we eventually find ourselves on a chord that sounds like 5/7 of 4. That old trick again. And it's not hard to imagine it going to 4 and then pressing ahead toward a D flat major cadence. But 5/7 of 4 in D flat major sounds suspiciously like an augmented sixth in F. So while we might be expecting this resolution, of course we get this one instead. And what follows is a mile-wide dominant of F. So there we are, folks. That's lesson 1 on enharmonic wormholes. Lesson 2 will deal with wormholes that use fully diminished seventh chords, which offer not one surprise path, but like 72,000. So look for it soon. And because classes just started, by soon I probably mean next summer, but it'll be worth the wait.